Yeah. Good morning, everyone. Am I audible?
Yes, sir.
Good morning,
Yeah.
sir.
Good morning, Neeraj. So let us start today's discussion. So before start today's session, I would like to uh, discuss again what are the topics we have covered in the previous session. In the previous session, we discussed about what is computing, and we have seen the definition given by ACM uh, regarding the definition of computing in the year of 2005. We have started our discussion on that. Then we have discussed the overview of this particular course, where I told you about different uh, characteristics, different standards, which are the basics related to the cloud computing. Then I told you about cloud computing architecture. I also discussed about the John von Neumann architecture. Then I told you about different types of cloud, like there is a division of cloud based upon the service model, and there is a division of the cloud based upon the deployment model. Then we have seen service management in cloud computing, in which we have discussed about the service level agreement (SLA). Then we have seen resource management in the cloud, data management in the cloud, something related to cloud security, cloud privacy, trust, and reputation. Then I told you about the different open standard, commercial cloud, and cloud simulator, and some of the research trends related to the cloud computing and fog computing. And we started discussing about the distributed computing in trends on computing. And apart from this distributed computing, we have grid computing, we have cluster computing, utility computing, and finally we have cloud computing, right? So last class, more or less, we have discussed about the distributed computing paradigm, and also we have discussed about some of the common properties of distributed computing. So let us continue our discussion with the distributed computing. Once it is done, then we'll go for grid, followed by cluster, and followed by the utility computing. Once these background technology or paradigms are completed, then we'll start the discussion on cloud computing. And if you remember in the last lecture, I told you about different type of application. Like one of the popular application I mentioned, that is called as weather forecasting, right? Or you can say some suppose we have captured a satellite image, there we want to do processing. Okay, so there are numerous of applications are there in the distributed computing, and not for all application you will apply distributed computing paradigm, but you will see where you have a goal oriented activity, where you need more computation power, where you need more storage. In such application, distributed computing is applicable. Then we have discussed about the difference between the compute intensive and data intensive. In computing intensive, I told you to compute the value of pi through Monte Carlo simulation. That is an example of your computing intensive. Where in data intensive, we deal with a large amount of data, like we are using Facebook, WhatsApp, any e-commerce website, social networking website, where it is data intensive, because number of users are very huge, and we are posting numerous things like videos, audios, images in the social media, right? So it requires data intensive application. It is a data intensive application. Then we have discussed that in comparison to the centralized computing, if you look into the distributed computing, it avoids the single point of failure. Centralized computing, there may be issues related to single point failure. If server is failed, then whole network is going to be collapsed. But when you go for distributed computing, you will not find the single point of failure. That is also one of the advantages. So if a node is failed, it is not going to impact other nodes, right? So that is the things we have discussed in the previous lecture. So let us discuss more about the distributed applications. So application that consists of a set of processes that are distributed across a network of machines and work together as an enable to solve a common problem, right? So we have a set of nodes in our distributed computing paradigm, and these nodes are placed in different part of the world, right? But together they are solving a particular problem. Sometimes we call this one as a single system image. Like as a user, you are putting a request to a particular computer system, and that computer system is responsible to execute the application whatever submitted by the user, and that computer system is also responsible to send the result to the user. But behind this computer system, there are number of systems are connected to that particular system, right? You may see here number of systems are connected behind this particular system. So when you look into user perspective, this whole system is looks like a single system. That's why we call that as a single system image, because user need not bother about what is the complexity of the environment. Like we are using Google services or especially Gmail, but we don't care that where the emails are stored, how these emails are maintained, what security policies are enforced in our email, where it is configured. We need not bother about it, right? But we want by giving username and password, by ensuring the internet connection, our email need to be retrieved, right? Our emails can be stored by authenticating our username and password, irrespective of the location, irrespective of the devices also. If any device connected to the internet, in that device you can view your emails, right? So for us also we call this entire thing as a single system image, right? So here also we are saying the same thing. We have a set of processes. You can see each and every computer system has one or more processes, and they are not in a single place. That's why we say it is a distributed one, and they work together to solve a common problem, right? Like weather forecasting, I told you a lot of computer systems in the background of weather forecasting project. So they work together to show you the temperature of next 5 days, next 7 days, right? So that is an example of your distributed application. But if you see past most, if you go previous to before this distributed computing, you will find mostly the architecture is called as client server architecture. Okay, client server architecture, client is less powerful, server is more powerful. So basically, client is making a particular request to the server, and server reply with the requirements given by the client, right? It is going to provide the resources to the client. It is going to provide some kind of requirements which is claimed by the client. So mostly the architecture is a client server architecture, right? But the problem we have noticed that there is a single point of failure. Single point of failure, SPOF, in the case of client server architecture. Okay, as the resource management is done in a centralized manner, so it may lead to centralized failure, which may collapse the network. So in order to avoid this client server architecture, we have the peer-to-peer computing. It is also a distributed computing paradigm, but here every node participated in the network treated equally. Okay, like you can see that suppose I am considering 4 different nodes here. They are connected to each other, right? In some manner, not there may not be direct connection. So here no computer is superior over any other computer system. There is no master slave relationship. They are autonomous systems. So together they are solving a particular problem. But if any point of time, if there is a particular system is failed, it is not going to impact on other system. So performance wise, there may be a slight deviation. Like if four computers are together to complete a particular work, if a particular system is failed, then the work may be delayed for some amount of time. But the system is not going to be collapsed, right? That is the advantage of peer-to-peer computing. And peer-to-peer computing is a true application of a distributed application. Okay, because it is not located in a single place and it avoids single point of failure. So let us discuss with an example. Like here you can see there are two clients. Let's say this is client 1, this is client 2. So client 1, client 2 connected to a particular server. Okay, like sometimes we are getting 30 licenses, right? For a particular software, we are getting only 30 licenses. So these licenses are given by the server. So whenever a client needs that particular server, the clients make a request to the server, which we call as invocation, or we can say request. So once a request reaches to the server will provide one of the instances to the client. For example, if we have a 30 license, so at a time, 30 clients can access to that particular software. If 31 clients start to access that particular service, software, then the service is denied. So in order to provide 31, one of these 30 users has to shut down, right? Or return that particular instance. Then only we can provide to another client. Okay. So once the request reaches to the server will check the requirement, right? Whether the requirement can be fulfilled or not. Like I told you, 30 license. It will check that whether it is within 30 or it exceeded 30. So based upon that, it will return the result to the client. Not only client, there are set of clients are connected to the server and their resource requirement is not same. A client 1 can request something, sometimes client 2 can request any other thing also related to some other thing. So it will make an invocation. Server will check that whether that invocation can be honored or not. If the invocation can be honored, then the server will provide that to the client. Not only this relation is always in between the client and server, but also this relationship can be in between the server to server also. Like we say that unlimited processing power or unlimited storage, but there is nothing called unlimited in real life. But together we can make it unlimited. Like here you can see, suppose client 1 makes the invocation to this particular server. However, whatever requirement given by the client 1, that is not available in server 1. Or server 1 is incapable to provide that particular resource. Then what this server will do? This server will make request to another server, right? So if that service is available here, then it will return that result to this particular server. Okay. Originally, the service asked by the client, but the service is not available in this server. Let's say server 1. Then server 1 makes a request to server 2. If resource is available in server 2 provide that resource to server 1. Then server 1 provide that resources to client 1. So not only this connection is always between client to server, but also in between server to server. So if you look into this client server manner, you can say it is a client server architecture. But when you say this server to server connection, it is a peer-to-peer architecture. Like server 1 is not superior over server 2, or vice versa is also true. Right? Server 2 is also not superior over server 1. But together what they are cooperating each other to give the resources. Okay, on in a agreement basis, maybe also sometimes they agree to certain terms and condition. By the help of the terms and condition, they agree with the uh, certain terms and condition. Based upon that, they are sharing the resources. Okay, so our objective is that as much as possible, whatever request the client is making, we have to fulfill that requirement, right? So in this way, the client is connecting with a server, or server is connecting with another server to make it truly unlimited, right? Now see another type of distributed application based on peer-to-peer process. So previous one you have seen some type of client server architecture, right? Or in this architecture also you can say when server 1 is making a request to server 2, server 1 is looks like a client and server 2 is a server, right? So each and every component or each and every process, so it may be a client, it may be a server. So if it is providing resources, then it is a server. But if it is requesting some service or some process or resources, then we call that as a client. But see this one here. What happened? We have different peers. This is peer 1, peer 2, peer 3, peer 4, peer 5, peer 6, peer 7. Like that, we have up to peer n. So these peers are connected to each other in some way. There may be a direct link or there may be a indirect link. Like here you can see peer 1 and peer 2 is not connected. Okay, there is no direct connection between peer 1 and peer 2. But peer 1 is connected to peer 4, peer 4 is connected to peer 2, right? Similarly, you can see peer 2 is connected to peer 3, peer 3 is connected to peer 4. Somehow they are connected to each other. Suppose as a client, I have made a request to peer 1, right? Some service I have requested to peer 1. So what happened? Peer 1 will first check whether whatever request you have made, that request can be honored or not. If the request is honored, it will get back that result to the user. Otherwise, it has to check with peer 2, peer 3, peer 4, peer 5, like that up to peer n, and borrow that particular resources and can provide that resources to the user. Okay, but peer 1 is not informing this user that the service is not available with me. I am getting services from some other peer. That's why this whole system is called as your single system image. So if you have requested to a particular peer, you are going to get the services from that peer without knowing that whether the service is provided by that peer or there is a large infrastructure behind that particular peer, right? And a peer can run multiple applications also. While it is running multiple application, for example, one particular application, it needs some resources from peer 2. Okay, or it is collaborating this application with another peer, right? Similarly, another application may be shared with peer 5, another application may be shared with peer 10, like that they are connected to each other. So we call this as a complete distributed system, as they are not placed in a single place. Okay, so in this way, actually, the distributed mechanisms, distributed applications are executed, and as they are not in the single place, we call that as loosely coupled system. Okay, because they are not dependent on each other. But parallel systems we have seen, they are dependent on each other. They share the same memory, right? So we call that as a tightly coupled system. Okay, so this is all about the distributed computing, which is the first part in the trends in computing. So let us heading towards the second type of computing paradigm, which is also called as the backbone of cloud computing, that is called as grid computing. So the term grid is not new. Like if you ask your uh, friends in electrical department, they will say they have also grid. They call that as a electric grid. Even if electric grid is there from long back, it is not a new thing. But now we say grid computing. It is a term related to our branch, right? It is not a electrical term, but more or less it is it is related to the electrical grid, right? We'll see how electrical grid is different from our computational grid. But before that, we'll see what is actually grid computing. So different people suggested different kind of definition for grid computing. Like if you see here, PC Webepedia, right? They suggested one definition. IBM has suggested one definition. Sun Microsystem, you know that Java belongs to Sun Microsystem. They have also suggested one particular definition. So let us discuss one by one. Last class also I told you in grid computing, it is nothing but aggregation of the resources, sharing of the resources where the nodes are heterogeneous in nature. Nodes are not homogeneous. Their architecture is different. Okay. So as per the first definition, it says it is a networking. I told you all are belongs to parallel distributed system and they are forming one type of networking, which is not like your conventional network. Conventional network is different. Client server network is called as your conventional network, but it is not same as our client server network. So here we have communication among devices, okay, and grid computing harnesses unused processing cycles of all computers in a network for solving problem too intensive for any standalone machine. So what you can get from this particular definition is that, for example, if I ask you, let us consider a bank. So you know, bank we have there are cashier who actually perform the different operations. Like withdraw is a operation, you can say deposit an operation. If you want to prepare and go for a demand draft, that is also one operation, right? And several operations you can perform, right? Several requests you can make in a bank. Suppose a cashier is working for 7 hours per day. Okay, 7 hours per day. And assume that there are 6 working days. Okay, 6 working days by considering Sunday is holiday. So how many hours the cashier is working? Tell me. If it is 7 hours per day and there are 6 working days, then
42 hours.
yeah, it is 42 hours. Let us consider there is a computer system given to this cashier and is using, okay, he is using this computer system for 7 hours per day. And rest time, suppose the total working hours is 8 hours or 9 hours. Rest time he is doing file work. It is it is not related to anything related to our computer system. So it is 42 hours. But if you see total hours in a particular week is, if I ask you how many hours are there in a particular week, how many hours are there per week?
84.
No, no, not 84. Check once, 24 into 7, right?
16, 168.
Exactly. It is 168. So it is 42 divided by 168, right? So if you calculate this, it will come as 1 by 4. Somebody mentioned about 84, right? 84 is 1 by 2, right? So 84 double is 168. So it is 1 by 4. So it is same as 0.25. What it indicates? It indicates that the utilization of this system, if it is switched on, we are not looking into the 100% utilization, but if a system is on, we consider the system is utilized, right? Later I will tell you computer utilization. So this system is on for 7 hours per day or 6 working hours. So 42 hours it is on. So utilization is only 25%, right? 0.25 means 25%. What about rest 75%? Rest 75% of time, this is completely idle. So grid computing harnesses this unused processing cycles. In computer we call it as clock cycles, right? So 25% we are utilizing, rest 75% of time it is completely idle. So our objective is to make utilize of this 75%. Okay, again in these 25%, what is the utilization? Whether it is 10% or it is 50% or it is 100%, that we are not looking into. We are calculating the utilization with respect to the uh, switch on of that particular system or system is active, then only we are considering that. So our objective is to get this unused processing cycle of the computer system, not only one computer system. If there are 1,000 systems are connected to a particular network, we are looking into whole network, not only a single device, right? We are looking into all the devices, how we are going to utilize it properly by taking their unused processing cycle, right? And where we are going to use this unused processing cycle, we are using this unused processing cycle in order to solve the big problems, like goal-oriented problem, complex problems, or you can say scientific engineering type of problem. And such a problem is not possible to done by a single machine, right? If I execute that type of project in a single machine is incapable to do that work, right? So this is the definition provided by this wikipedia.com, right? Let us come to the second definition provided by IBM. So grid computing enables virtualization of distributed computing. So virtualization is a popular technology behind cloud computing. Similarly, in the grid case also, it is a very popular term. What virtualization says? Virtualization says that if we can utilize the physical machine, okay, like one physical machine is dedicated to a particular user. So when this user is using this physical machine, it is active. But when the user is not using this physical machine, then it is completely idle, right? So but instead of a single user, if multiple users are using the same physical machine, then what happen? Utilization will definitely increase. Like if a system is there, it is used by one person. On the other hand, that system is used by multiple people in some sense. Then obviously if multiple people are using, the utilization is going to increase, right or not? So what actually we are doing here, this is possible by the help of the virtualization technology, right? We can utilize the resources of a physical machine by creating different virtual machines. In order to create this virtual machine, we use a technology that is called as virtualization technology. Okay, so grid computing enables this virtualization of distributed computing and data resources such as processing, network bandwidth, and storage capacity to create a single system image, right? Sometimes for a user, a particular physical machine is not sufficient. Like I told you, stand-alone machines are not sufficient. So you want more physical machine, right? Let's say if you combine two physical machine, then your work can be done. So that is also possible. When you require, you can split a physical machine resources into multiple resources. When it is required, you can combine one or more physical machine also. So this looks like a single system image. Okay, and we are granting users and application seamless access to vast IT capabilities. So these resources are provided to whom? This resources is provided to user. So based upon the type of application user require, you can decide how to split a whether to split a particular virtual physical machine or to combine multiple physical machine. Okay, so whether you require a small amount of resource or you require a large amount of resource, that will help you to provide uh, multiple access, or you can say that will also provide you some resources to the user, which is going to overally utilize that particular resources. Okay, like here one example you can see, just as an internet, users view a unified instance of content via web. Like, we do not know how internet actually works, we do not know how many websites are there, we do not know in which server the website is accessed, right? But irrespective of that, we have a web browser. In web browser, if I type a particular URL, that is uniform resource locator, I am able to get the services from that particular site, right? So that's why it says the internet users views a unified instance of content via web. So a grid user essentially sees a single large virtual computer. So for a user, this entire thing is a virtual organization or a large virtual computer. Like, if I take an example, like let's say there is a organization A. Organization A is having, let's say, 10 servers, right? Let's say organization B is having 20 server, right? And let's say you want to run a particular application, right? And in order to run that application, you need 25 server, right? Organization A is having 10 server, organization B is having 20 server, and you want to run a particular application which requires 25 server. So if you ask organization A regarding 25 server, organization A cannot provide, right? Because 25 is much greater than your 10. If you ask organization B, it will tell you that only I can provide you 20 different server, right? But I cannot provide you 25. So your application cannot be executed by taking the resources of organization A or organization B. So what you can do, you will request organization A and organization B to collaborate each other. Okay, or you want to run this application in collaboration with organization A and organization B. So whole total you have now 30 servers and your requirement is 25 server. So it will fulfill your requirement, right? So here you can see in this context, if you see for a user perspective, it is nothing but a large virtual computer system. Okay, together they cannot do, but by combining they can provide the resources to the user, right? So that is also possible by the help of grid computing and cloud computing paradigm. Next, come to Sun microsystem. That is Java provides. Java is also a popular platform which is provided by Sun microsystem. What they mentioned, grid computing is a computing infrastructure that provides dependable, consistent, pervasive, and inexpensive access to the computation capability. Try to understand dependable. Dependable means is all are cooperating each other to execute, all are together to execute a particular application. In that context, we say they are dependable. Consistent means you can see, like one organization to another organization. Okay, one organization to another organization, right? There are number of users can join, right? If you see a particular project, number of peoples are joining and number of peoples are leaving at any point of time. Like one of the popular project of undergrad, that is called as SCTI at home. You can note down this and you can search for it. That is called for Search for Extraterrestrial Intelligence, SETI at home. So if you look into this particular project, you will see some lakhs of PCs are on at any point of time, and these lakhs of PCs, okay, are not belongs to one organization. They are not belongs to one particular organization. They are part of different organizations. So if they are part of different organization, anybody can join and anybody can leave at any point of time, because they are not under control of the a particular administration, right? And as we are talking about distributed computing, they may be part of a different country, also different continent, different country, different organization. So there may be internet issue also, there may be also, you can say, security issues are also there, right? So any point of time they can join and leave, but irrespective of that, you can see this particular project is having some lacks of computer system. So in that manner we call that as a consistent. Okay, and these resources are inexpensive. Sometimes if you want to share your clock cycle, your computer clock cycle, you can join the project, and whenever you are not using your computer system, you can give these resources to such type of platforms, okay, or such type of projects, right? That's why it is called as inexpensive. No need to pay a high amount. Even if they are going to give some amount to you, that is very nominal amount, right? So we can get the computational resources with minimum cost, right? Now, as I said, this term is uh, if you compare with the traditional term, that is called as electric grid. Like when you go to a particular dam, right, you can see uh, there the electricity is generated. Okay, electricity is just generated and stored in that particular place and transferred to some location where electricity is required. So that is called as electric power grid. Generally they are following a particular structure like this, in row and column structure, and you can see there are different poles are there. These points are nothing but your poles, right? They are generating electricity and storing in this particular grid and transferring to some location where electricity is required. So when you go for electric power grid and compare with the grid, so let us see what is the difference. Like if you go for electric grid, users or electrical appliances get access to the electricity through wall sockets. Like in our you can say home, or in our place also you have switchboards, right? Every room you have switchboards. Okay, so if you switch on the switch, then you are getting electricity. If you switch off it, then you will not get electricity, right? But we need not worry about that. No care and consideration from where and how the electricity is actually generated. Okay, we least bother about that, where electricity is generated, how it is transmitted, although it is a electric grid or power grid, you can say, but we are not really interested for that, right? So power grid links together power plants of many different kinds. So main objective is that it is a massive power. We have a massive electricity power, and it is connected to different part. So whenever electricity is required, or there is a scarcity in the electricity, usually it is connected to some location, and also some surplus electricity is stored some place, right? So whenever there is a requirement in a particular place, then it is going to provide it to that particular place. That is the purpose of electrical power grid. Now come to grid. Here also the concept is related to the electric grid only, where user or client application gain access to computing resources. Like if you use cloud and grid, you will get computing resources. What do you mean by computing resources? It may be processors, it may be storage, it may be data, it may be application, or it may be anything, right? Is needed whenever you require it, whether it is night too, or it is early morning, or it is afternoon, or it is noon, doesn't matter. Okay, and you have a little or no knowledge of where those resources are located. In fact, it is no knowledge only, but if you are aware of that, where these resources are provided to you, like if you go for cloud service provider like Amazon, you have Amazon has divided whole world into different region or availability zones. So by looking into that, you have some knowledge that in this particular place, I am getting some resources. So you have a very little knowledge or no knowledge of where these resources are located and where these resources are provided to the user. So we also not aware of the underlying technology, how these resources are connected, what is the bandwidth, uh, and you can see whether any third party is going to maintain it or the service provider has maintained it. We don't have any informations. We have no idea about hardware, operating systems, and others. So instead of these things, what we need? We need service. We are not looking into these particular terms, right? So the grid links together the computing resources, either personal computer or workstation or server, or you can say supercomputer in a large scale, and provides the mechanism needed to access them. Okay, our objective is to, whenever user require a particular service, you have to provide it, right? Now, let us see when to use grid computing. Right? At what point of time you need the help of grid computing? Already we discussed that weather forecasting project where you require large computation power. There you can use grid computing. Like during COVID time also, many people they want to develop vaccines, right? In order to develop vaccines, also large computation power is required. So they can also use grid, right? So grid actually mean that we have to share more than information. Not only the data and information will help you, but also you have to share your clock cycle or computing power and application in the dynamic environment. It may be multi-institutional and virtual organization. It is not limited to a particular organization or a particular company. Okay, multiple companies need to group together in order to provide resources so that a particular application can be executed or you can generate the result for that particular application. Similarly, efficient use of resources at many institutes. Like if a particular institute you can see, like our organization, if you see in our organization, maybe 1,000 or to 10,000 computers are there. But as it is educational institutions, except some labs, most of the labs are closed in the night time. Most of the labs are closed during vacation time. So such resources we can provide to run a particular applications. So people from many institutions working to solve a common problem. Okay. So that is how they are collaborating each other through a virtual organization. Nobody know how they are collaborating each other rather than in the background, in the underlying background, you can see most of the organizations are collaborated each other and they agreed to share the resources so that a particular common problem and application can be executed. Similarly, sometimes if you need the resources, you can join the local communities. Like nearby universities, you can request if you want, if you feel that a particular application is not sufficient by the help of whatever resources available in your institute, then you have to request to the nearby institutions. Community means nearby institutions, nearby organizations to participate in that particular application. So together you can execute that application. The last one is interaction with the underneath layers must be transparent and seamless to the user. So virtual organization does not mean that you can compromise in the security. Right? Virtual organization says that the user will not see this complexity of the environment. If user will see the complexity environment, user is not willing to use that particular you can say particular technology, right? So for that context, it is virtual organization, but it should be very transparent. right? Nobody is going to steal some information from other people or other computer systems. Okay, and these services is going to provide it to the user. Now, see here, what is the need of grid computing? Okay, so as I told you, standalone computer system, like our computer system, if you see, we have some GB of RAM and some TB of hard disks, right? So it is not sufficient. It is not sufficient to run an application. Okay, if you want to run a big application, it is not sufficient. Even if you increase the size of your RAM and TB, it is not a wise solution, right? Because once that application is over or this application period is over, right, that is of no use, right? So in such a cases, you have to collaborate with the other computer system. So today's science or research is based upon computation, data analysis, data visualization, and collaboration. Like I told you about satellite image. Like early days, if you see, if you capture a photo that comes under KB, some KB, but now it is coming in MB. But when you go for satellite image, the image is coming in some GB or more than that also. Okay, so how to process that, but that kind of images, that is really challenging, right? So there, grid computing can help you because you need collaboration. You want to visualize a particular application, there also it is helpful. Similarly, computer simulation and modelings are more cost effective than experimental methods. Like if you do experimentation, like you know that in physics chemistry lab also you have done some kind of experimentation. You are dealing with the real instruments, you are dealing with the real chemicals. Okay, so it is costly, right? But when you go for simulation, right? Simulation is you can use by the help of a software. Okay, simulation can be created by creating a virtual environment. So simulation is a cost-effective solution than the experimentation. So once you succeed in the simulation, then you can look into the experimental perspective. Okay, that's why most of the cases, most of the tools, whatever we are using, that is providing a simulation, not the experimentation. Like 3D printing nowadays, people are saying 3D printing is what we are doing. We are generating, we are developing small toys, right? These all are nothing but prototypes, right? Once we succeed in that, then you can think about a big one, right? So for prototype case, we are also using computer simulation and modeling. So scientific and engineering problems are becoming very complex, and user needs more accurate, precise solutions to their problem in shortest possible time. So sometimes if you run a particular program in your computer system, it is taking, let's say, some hours. But when you divide that problem into small parts, right, and can take help of multiple systems, it can be faster. So within a shorter period of time, you will able to process a large amount of thing, right? Or you can solve a particular problem, right? That will be very helpful, right? Because the time is drastically reduced by the help of multiple system. So where we will get this multiple system? By the help of grid computing system. So there is a platform you can type in Google about BOINC. Okay, all of you can type in Google about BOINC. It stands for Berkeley Open Infrastructure for Network Computing. Let me show you. Here you can type BOINC platform. Okay, this is Berkeley Open Infrastructure for Network Computing. Okay, if you download this BOINC, okay, you can go to BOINC, and if you want to join, then you have to download it. Okay, it is a project sponsored by National Science Foundation, NSA. So like I mentioned you about weather forecasting is also a part of this particular project. So once you have installed this software in your computer system, right, then you can participate into the grid projects, right? So let me share this link with you. For those who are interested, you can note down this website and you can participate in the any number of projects. So once you participate in the project, when your computer system is idle, they are using the resources of your computer system. Okay, they will use the resources of your computer system and they will execute some application in your system. So you will see your computer utilization is very close to 100%. If you check the performance by pressing Control Alt Delete, right? Like if I press your Control Alt Delete, if you go for Task Manager and look into your computer performance, so it is very low, right? You can say utilization is only 10%, 11%. But once you have installed this BOINC platform, then you will see the utilization will be close to 100%, right? So whenever your system is idle only, then they are to use these resources. So there also you are using the resources from the grid computing, right? Because you can share resources. Tomorrow you have decided not to share the resources, that you can do. So anytime you can join with any number of projects in the grid, anytime you can leave from a particular project. Okay. Similarly, data visualization is also very important. Okay, nowadays we say data science, right? In data science, you will see there are different type of visualization techniques are there. Like we have scatter plot, we have bar plot, we have pie chart. Different charts are there. So that visualization purpose also, if you do with a large system, okay, that there also you can use grid computing. And basically, our objective is to use the underutilized resources. If a resource is underutilized, we can take the help of such resources and use that resources. Okay, we want to use such resources for some needy purpose, right? Like running a particular application. So see here you can see there are different type of grid nodes are there, and these grid nodes may not belongs to the same organization. They may belongs to different organization. Like it is belongs to one organization, it is belongs to another organization. Maybe the time zone of these two organizations are also different. Okay, it maybe belongs to one particular time zone. Let's say Greenwich time. You can say if you GMT time, if you calculate, and this may be in Indian Standard Time, right? This may be in another standard time, right? Different times are there, right? But together they are creating a single system image or providing you the virtual organization to run different kind of projects. Like weather forecasting, I already told you. Similar application related to the physics or crystallography or detection and modeling natural disaster. Earthquake also, earthquake applications also is a part of our grid computing project. Reactor application, material characterization. In such applications, you can use grid computing. Okay. So grid is not limited to a particular application. Number of projects you will find under this BOINC platform. Like the project related to physics, chemistry, and mathematics. It is one group, chemistry and mathematics, right? It is one, you will find a set of projects related to this one. There is a set of project related to computing. Okay, there is a set of project related to astronomy, right? And so on, right? You will see more than, to the best of my knowledge, 50 around 50 projects are running under the grid computing, where none of the systems are belongs to BONC, that is University of Berkeley. BONC actually this platform is developed by University of Berkeley. So some systems are given by this Berkeley, University of Berkeley, but rest systems are belongs to different organization, right? So like that, different projects. If there is a scientific engineering projects are there or any complex project you want to do, you can make use of grid computing. Now we'll see there are different types of grid. So basically there are four different types of grid. One is called as computational grid. Second one is called as data grid. Third is collaboration grid. fourth is network grid, and fifth one is called as utility grid. Let us discuss one by one. Like already we discussed about what is computation intensive or computing intensive and what is data intensive. Right? We have already discussed computing intensive and data intensive, which is same as your computational grid and data grid. So computational grid means you have a huge pool of shared processing power. We are dealing with the processing power, but data means we deal with a large number of storage, large amount of storage. So computational grids provide secure access to huge pool of shared processing power suitable for high throughput application. Try to understand. There is a two different type of application. One is called as high performance application. Another is called as high throughput application. Although both looks similar, but they are different, right? Or you can say this is related to HPC and high performance computing. It is related to high throughput computing, right? So HPC and STC. In HPC case, what happened? Like we are using more or less more CPUs, less GPUs, right? You know there is a difference between CPU and the graphical processing unit GPU. Okay, GPU is more powerful than CPU. What is the difference? Can anybody say between CPU and GPU? CPU and GPU, what is the difference? Anyone, any guess? CPU and GPU. In CPU case, like I told you about von Neumann architecture. You have control unit and you have ALU, right? So if you see, the most computation is done by ALU, right? Addition, multiplication, subtraction, any operation you want to do, this arithmetic logic unit, right? ALU performs that thing. But when you go for GPU, you will see more ALUs, right? There are more parallel units are there. So it is low compute in density, but it is high compute density. Okay. So as ALUs are more, you can do much computation in comparison to this one. So CPU can provide you high performance, but through GPU you can get high throughput. So here we are looking for high throughput application. Again, in high throughput also you need high performance, right? But in high throughput, what you have more ALUs, so you can do faster computation. You can get better result in less time. Okay, the execution time can be very less, right? And it is also the computation intensive computing. Okay, because we are dealing with a large processing of power. So when you need large processing of power, you will go for computational grade. But when you need the things related to the data, like your data grids provide a infrastructure to support data storage, data discovery, data handling, data publication, data manipulation of large volume of data. Okay, computation and data, they are different from each other with these two terms. One is processing power, another is the data. Okay, and these data are stored in different databases, and these databases are also not same. They are configured differently. Okay, they are providing different facility. That's why we call that is heterogeneous database and file system. In this way, the computational grid is different from the data grid. But when you go for cloud, you will find cloud wants to achieve high throughput application, not high performance application. But if you go for the traditional computing, even if in the grid computing, we more focus on high performance, not high throughput. But here we want to focus on high throughput application. There is another grid that is called as collaboration grid. Okay, collaboration grid means I told you about two different organizations, right? Organization A, organization B. They need to collaborate each other to execute a particular application because individually their resources are not sufficient. So there has been an increased demand for better collaboration. Okay, such advanced collaboration is possible using grid. For example, persons from different companies via virtual enterprise can work together in different component of computer aided design project, and they don't even disclosing their proprietary technology, right? Like in the software development process, starting from the requirement to delivery of the software, there are number of phases we have, and these pages are executed in different part of a particular company. Okay, like in multinational companies, they are situated in different part. Like one may be at New Delhi, one may be at Mumbai, another may be at Kolkata, another may be Bangalore, Hyderabad, and other cities, right? So they can collaborate each other to complete this particular project. So they don't want to reveal the proprietary technology or underlying technology. Okay, still they can use complete that particular project. So in that case, when multiple locations people are joining through a virtual enterprises, we can use the collaboration grid, right? Is another form of grid, but irrespective of different types of grid, our objective is to provide resources to the user. Okay, so let us